Assalamu alaikum all. Today my assignment topic is polyurethane based piezoelectric sensors and their application in medical industries. First of all, let's have a look on the thing that we are going to discuss in this presentation. First of all, we will understand what are piezoelectric sensors, then what are the types of piezoelectric sensors, what are polyurethane and polyurethane based piezoelectric sensors and their application in medical industries, and at last we will have a look at um, different literature that has discussed polyurethane based piezoelectric sensors applications in different medical industries. Now, the piezoelectric sensors are any gadget or device that uses piezoelectric effect to transform the mechanical energy into an electrical signal. Basically, that mechanical energy can be in the form of a pressure, in the form of force, or any kind of disturbance that is created in a material, and that disturbance is transformed into an electrical signal. So what happens is that when a force or pressure is applied on a piezoelectric material, it bends and create a temporary dipole. This temporary dipole allows passage of current through that material. So when the pressure is lifted, that temporary dipole that had been created earlier is now uh, ended and the material comes into its original shape. We'll not go to details of this process. We will shift our focus onto applications of piezoelectric sensors and polyurethane based piezoelectric sensors. So there are mainly three types of piezoelectric sensors or piezoelectric materials. First of all is inorganic based. These materials include piezoelectric films, ceramics or single quartz. Usually elements are added into these piezoelectric material to enhance their characteristics. Second one is organic based piezoelectric material. There are many varieties in these categories, but the major ones are polylactide, polyvinyl, polyvinylidene fluoride, and polyvinylidene fluoride trifluoroethylene. So there are many compounds in this category, and the third one is composite piezoelectric materials. These are obviously these are the compounds that are made by mixing organic or inorganic materials together, or by making small modifications in either organic piezoelectric materials or inorganic piezoelectric materials. The sensors, which are based on mechanical impedance, usually in these categories of sensors are mounted on any materials, and we apply an electrical voltage signal, and this signal is converted into a mechanical stress. Now the mechanical stress interact with the material, and material gives us output in the form of electrical signal, which and that electrical signal is uh, measured, and we get the mechanical properties of that material. For example, in electromagnetic impedance sensors uh, are used in medical industries to locate and identify any damage uh, that has been created in bone, or the damage that has been created in a plaster, or any kind of damage that has been created in a joint. So basically what happens is we apply a mechanical stress into the joint or into the bone, and uh, the bone or the joint gives us an output in the form of electrical signal, and that electrical signal is again recorded, and we come to know about any kind of deformity, or we come to know about the overall structure of the material. In the sensors that are based on guided wave or ultrasonic propagation, the sensor will transmit signal to the region, and the region uh, would either reflect back that transmitted signal, or change the wavelength of the transmitted signal, or cause any kind of change in the transmitted signal, and sensor will detect the change in wavelength or change in intensity of the transmitted wavelength. So this works in four different ways. First one is pitch catch, where a signal is transmitted into the any material that is in concentration. The sensor would have a transmitter and a receiver. Signals are transmitted, and uh, the wavelengths that are transmitted to the material is recorded, and if a material passes through any damaged region, it will transmit the wavelength of different kind, and which will be detected by the receiver. In second one, pulse echo mechanism, the transmitter will transmit the signal, and if there is no deformity in the structure or material, that the waves would pass unaffected. But if there is any kind of damage in the material, the wave will reflect back into the receiver. The third one is thickness mode. Here a thickness gauge is used, and the waves are transmitted, and thickness of the waves are usually recorded from the in the receiver. And the fourth one are impact. These are usually these are the sensors which are used to detect the point, or the potential point of impact, uh, when the deformity or when the crack has already appeared in the material. Now the third one are the sensors which are based on acoustic emission or stress waves. These are the sensors when any kind of strain energy is applied to them. They uh, give off signals in the form of um, sound waves or related waves. For example, uh, if a crack appears, or there is a fiber breakage in the sensor, it will transmit sound waves. This kind of sensors are usually used to uh, monitor or to sense the breakage of bone or the breakage of any muscle fibers. Now, what is polyurethane? Polyurethane is primarily made up of oligomeric polyols as soft chain segments and diisocyanate and small amount of chain extenders that will increase the chain length. Polyurethane has variety of functional group attached to it, so it can attach different kind of material and is available for multi modification, including anti-aging, antibacterial, anticoagulation, self-healing, and degradation. By modifying the ratio, structure, and molecular distribution of soft and hard segments, there are soft and hard segments present in the polyurethane, and we can make changes in those segments and customize its property and enhance its efficiency and different related properties. So polyurethane piezoelectric sensors are vastly used in medicine, but there are 3 to 4 major kinds, major fields where these sensors are being used. First of all, they are used to monitor any uh, physiological changes in the heart or in the brain, like blood pressure, heart rate, or glucose level. So it is used to, first of all, it is used to monitor any health indicator. Second, and the most important one, is its use in sensor technology. uh, Basically here, polyurethane will not directly act as a sensor, but rather it will act as a protective coating um, for other sensor. As polyurethane is very flexible and hard, it would be an excellent protecting layer for the other medicinal sensors. Moreover, TPU is thermoplastic polyurethane, is also used for applications in defense application. Defense application, as I have discussed earlier, is to protect other sensors from any kind of mechanical stress or any kind of mechanical or environmental stress. Second, furthermore, polyurethane has been used in many medicinal fields. For example, a recent research from Amelias and showed that thermoplastic polyurethane perform better than other materials. Moreover, when integrated thermoplastic polyurethanes are compared to uh, other sensors like FBGs, they show high temperature sensitivity, which means that they would sense the temperature much faster and much efficiently as compared to the other sensors. At last, we will discuss different researches that have been done relating to these piezoelectric materials. First of all, Mr. Costa um, did a study on lead zirconate, titanate, rods, and castor oil polyurethane. He combined these materials to create a piezoelectric composite with a 1-3 connectivity and uh, to 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 study his sound sensing capability. Second, Mamoon, he developed a new piezoelectric form for transducer application by combining flexible polyurethane with calcinated waste eggshells. When this composite was compared with other piezoelectric materials, it shows um, an, uh, an effective piezoelectric coefficient and which would make him a perfect candidate for piezoelectric component for production of medicinal ultrasonic transducer or ultrasonic non-destructive testing to find flaws in various solid materials. Moreover, Yazdani he created a thermoplastic polyurethane elastomers composite with varying concentration of lead zirconate titanate ferroelectric particles via solution casting technique, and he analyzes the DMTA analysis of that composite material shows that the the lead zirconate titanate content significantly influence the magnitude of loss factor. Loss factors are basically uh, relates to loss of sound, which happens during sound detection. A material which absorbs more sound waves have a greater loss factor, and the material which loses less sounds while sensing the sound has a great less loss factor. So in short, the material which loses less sound is more favorable for acting as a sensor. And at last, Song, he also studied the coaxial electrostatic spinning process, and he created a thermoplastic polyurethane, which is polyvinylidene fluoride, a nanofiber membrane with a core shell structure in order to create flexible piezoelectric mechanosensor. So this sensor will um, sense the motions, and they show a wide sensing range of 0.2 to 5 kilopascals, very low reaction time, and very high sensitivity. So these all uh, researches shows that polyurethane based piezoelectric materials have a great potential in medicinal field, and mostly as a pressure sensor or mechanosensor. Thank you. That's all from my side, and and uh, any questions are welcome.